Okay, we are ready for number 5 on the review problems. It says 90% of the households in a certain town have high-speed internet service. If 6 households are chosen at random, what is the probability that all 6 have high-speed internet? Well, I can think of 2 different ways we could approach this question. One way would be to treat it as an and question. All 6 means that the first one does, and the second one does, and the third one, and the fourth one, and the fifth one, and the sixth one. So for an and question, we can use that multiplication rule. You answer and questions by multiplying. You answer or questions by adding. But for and questions, you multiply the probabilities together. So here, each individual probability is going to be 90% or 0.90. So when we multiply together the probability of the first household having high-speed internet times the probability that the second one does, times, we're really multiplying 0.90 times itself so that there are 6 of those in all. Another way to write that is 0.90 to the 6th power, and that comes out to be 0.531. So that is the answer to the question. 0.531 is the probability of all 6 having high-speed internet. The other way I can think of to answer this question is to treat it as a binomial probability question. There are 6 trials, 6 households that we select, and each one of them might or might not have high-speed internet. For each one, the probability that it does is 90% or 0.90. So we're looking for what's the probability that X, that is the number of times that actually does happen out of the 6 times that it could happen, turns out to be all 6. So this would be a binomial probability question where N is 6, P is 0.90, and X is also 6. So we could pull up that table for the binomial distribution, or use the binomial probability distribution formula on a graphing calculator or something like that. But we go to the place where N is 6, that's this section of the table. We go to where P is 0.9, and then we look in the row where X is 6. And the number we find on the table is 0.531. So that's the same probability as the other way we figured it. Now, question B. If 3 households are chosen at random, what is the probability that at least one has high-speed internet? So we could keep on thinking of this in terms of binomial probability. This time, P is still 90%, 0.9, but N would be 3, and we want the probability of X being at least 1. So not just 1, but at least 1. Could be 1, could be more than that, could be 2, could be all 3. So on the table, if you go to the part of the table where N is 3, and we need to add together all the probabilities for all the X's that are at least 1. So that would be the 0.027 for where X is 1. That would be the probability that it's exactly 1 out of the 3. Plus the 0.243 for the probability that it's 2 out of 3. Plus the 0.729 for the probability that it's 3 out of 3. So the probability that it's at least 1, that is either 1 or 2 or 3, if we add those together, they add up to 0.999. Notice that takes care of all the possibilities except the one where X is 0. So we could have just taken 1 minus the probability that X is 0. So that's another way to think of this. The probability that at least one of those 3 households does have high-speed internet The complement of that, the complement of at least one having it, would be where none of them have it. All three do not have it. So the probability that at least one does would be 1 minus the probability that all three do not. So that would be 1 minus the probability that the first one does not, times the probability that the second one does not, times the probability that the third one does not. Remember, if there's a 90% chance that they do, there's a 10% chance, 1 minus 0.90 is 0.10, a 10% chance that they do not. So the probability that all three do not is 0.1 times 0.1 times 0.1, or 0.001, and then 1 minus that is 0.999. So whichever way you get it, the answer to part B is 0.999. Number 6, the Interplanetary League Executive Council has 17 members. Of those 17 members, 6 are Earthlings, 7 are from Mars, and 4 are from Jupiter. 3 members are chosen at random, without replacement. That means once you've chosen the first one, you don't put that person back and choose again. You choose 3 different members. What is the probability that all 3 are from Mars? So when you see words like that, all 3, think, ooh, this is an and question. All 3 of them being from Mars means that the first one is from Mars, and the second one is from Mars, and the third one is from Mars. So how do you answer and probability questions? With the multiplication rules. You multiply the probabilities. And here these are dependent events. The probabilities are going to be different each time. So we're going to be multiplying together the probability that the first one is from Mars times the probability that the second one is from Mars if the first one was, times the probability that the third one is from Mars if the first and second were. So that would be 7 out of 17. So on the first pick, you've got 7 ways of picking somebody from Mars out of the 17 that you have to choose from. And then if you've already chosen one of those 7 Martians, the probability that the second one you pick is one of the ones from Mars, if the first one was, would be 6 Martians remaining out of the 16 members that are left to choose from. And then in that case, the probability that the third is from Mars would be 5 out of 15. Then we still have to multiply those 3 fractions together. So 7/17 times 6/16 times 5/15 equals 0.051. Don't forget to multiply these. Your final answer is what you get when you multiply those individual probabilities. What is the probability that at least one is not from Mars? Okay, big hint, we're going to be using the answer to part A to answer part B. What's the relationship here? Well, these are complementary events. It's always going to be one or the other. Either all 3 are from Mars, or there's at least one that's not. So the probability that at least one is not from Mars should be 1 minus the probability that, no, it's the other thing, it's that all 3 are from Mars. So we just have to calculate 1 minus 0.051, and we get the answer 0.949. What's the probability that all 3 are not from Earth? So this is another one of those all 3 questions. The first one's not from Earth, and the second one's not from Earth, and the third one's not from Earth. So we got to multiply together. What's the probability of the first one not being from Earth? Well, how many ways could that happen? 7 plus 4, that's 11 members who are not from Earth out of 17 in all, times, if that happened, under that condition, the probability of the second one not being from Earth would be 10 over 16, times 9 over 15. And when you multiply that out, you get 0.243. So that's the probability that all 3 of the members you pick are not from Earth. They're all 3 chosen from among the 11 non-Earthlings instead of the 6 Earthlings. And then what's the probability that at least one is from Earth? Again, that's the complement of that. So the probability that at least one is from Earth would be 1 minus the probability that all 3 are not. So 1 minus 0.243 is 0.757. Next question. For each of these, tell whether or not it could be a valid probability distribution. So here we've got a list of possible values for our random variable x. According to this, x could be either 1, 2, 3, 4, or 5. And then we've got what the probabilities are for each one. So this would be saying that the probability of x being 1 is 0.23. Okay. And the probability of x being 2 is 0.41. The probability of x being 3 is 0.15. The probability of x being 4 is 0.66. And the probability of x being 5 is negative 0.45. Wait a minute, that can't be true. You can't have a negative probability. So no, that is not a valid probability distribution. So that's what you have to look for. The probabilities have to be between 0 and 1. They can't be less than 0, that is, they can't be negative, and they can't be greater than 1. Next one, here if we look at these probabilities, they look okay. Each individual probability is somewhere between 0 and 1, so that's okay. But then the other condition that we have to check is that the probabilities have to add up to a total of 1. So 100% of the probability has to be distributed to all the possible values of the random variable. So here, if we add up these probabilities, 0.10 plus 0.20 plus 0.20 plus 0.30, that adds up to 0.80. So because they don't add up to 1, that's a no. That could not be a probability distribution. Next one, this is saying that x, our random variable in this probability distribution, could be 2, 7, 11, or 12. So that could happen. And then here we've got a probability for each one. And if we add these probabilities together, 0.51 plus 0.31 plus 0.11 plus 0.07 does equal 1. So yes, this could be a valid probability distribution. And I'm going to stop this video here and then come back in part 3. You can watch that right away, or you can take a little break and come back later and watch that one. But in part 3, we'll continue on with some more of these review questions.